All right, we're going to be doing a lot of Excel and Mathematica. So here you're given an exponential function and you have an x coordinate, y coordinate, x coordinate, y coordinate, and you're asked to find what the a and the b is. That's not explicit, but that's what you're asked to find, estimating the parameters. So I'm going to pull up Mathematica. You can find these by hand. In fact, that's how we used to do it, but I kind of am in agreement with Stephen Wolfram, who says that that kind of mathematics is dull. So here's what we do. We first of all type in solve with a capital S and a heavy bracket. Then we take a curly bracket. In for the y value, I'm going to put 6, which is my first y value. 2 equal signs, a times b raised to the 1. With this x and this y, it's supposed to fit that curve. I just don't know the a and the b. Dr. Wolfram's going to find that for me. Again, I do the same thing with the other point, 24. I put a comma, 24, 2 equal signs, a times b cubed. So the x is 3, the y is 24. Close your curly brackets, put in a and b, and then shift enter. And you get 2 solutions here, but RB for our exponential models is always greater than 0. So it's this solution that I'm interested in. So it gave it to me. Now you can do this by hand by using logs if you want. I don't want to. So that's what I have to solve. Stick it in a Mathematica. I got a equals 3, b equals 2. It's a cooked problem. Real life never works out that nice. But here we have f of x is 3 times 2 to the x. That's what would go in here, 3 times 2 to the x. I am at a 5-minute limit with Loom, so I'm not sure if I'm going to be able to get this problem all the way in. Let's try. So here's a model for bacteria, and I'm asked to compute the average and the SST. So what I did is I copied and pasted this data. You can actually type in the data by hand if you want. And the average in Excel, you just do equals average. You'll see it actually show up here. And you'll click it. And you'll put B2 to B with a colon and B6. And you see it highlight all of those. Close the parentheses, and this is the average. So this is what goes into the Y bar. It's what we call the sample mean. You'll hear it in 206. It's called the sample mean. The next thing you want is SST. SST is actually, sum squared total, is actually, the average is a model. And I'm going to call this SS because it's sum square from, let me call it sum square mean. That doesn't make sense, but it's the sum square, it's the distance from the mean. So here you want to have equals 1111, actually it's B2, sorry, B2. But I'm going to subtract off the mean. So I'm going to take the distance from B2 to the mean. And that would be in B7. But I'm going to put a dollar symbol here because I don't want that to scroll. And then I'm going to square it. That's a sum squared of away from the mean. This is pretty far. And then I'm going to scroll this down. And those are all the sum square error for the mean being a model. The mean is called, the sample mean is called the null model. And then here we go, sum of C2 to C6. See, it highlights them all. So it's sum C2 colon C6. Hit enter, and that's the sum square total. And so that's what goes here. Sum square total is that number right here. Last thing is they're assuming the bacteria growth is exponential, and they need to estimate the horizontal asymptote. Which one controls the horizontal asymptote? Well, it's the D. Because there's a couple ways to look at this. If I just graphed, let's say I graph plot 2 to the x. X goes from, I'm going to put -1 to 10. So you can just, let me do 5 so you can see it. So that's how you plot something. And then you'll see that. And you see that this decays down to 0. If I want to lift that curve up, I just add something to it. Plus 10. That wasn't good enough for you to see it, but let's do 100 so you can see it. It's actually shifting my origin. So you see that at x equals